Good evening, everyone. Thank you for tuning in to our monthly webinar. Tonight we have Robin Earl here from DEHN here. He's going to be talking all things surge protection. He'll be sharing some great technical advice, and if we have time at the end, we will cover some questions and answers. If not, a quick reminder, if you do ask any questions on the live Q&A, to make sure that you put your membership number and full name on. That way, if we don't get time to answer them, I can get a full response to you from Robin, and I will email you something over. I'll pass you over to Robin now, and like I say, any questions or answers, just go ahead and we'll get it either sorted at the end of the show or today. Thank you.
Thank you, Fran. Thank you very much for that, and good evening, everybody. As you heard, my name is Robin from DEHN, and we're going to look at surge protection this evening. It's going to be sections 443 on the risk assessment and 534, which is how to fit it, basically. So, looking at 443, this is the risk assessment now in the 18th edition, and there's a couple of main characteristics and changes here. And the first one is that this section is no longer just about lightning, as it was in the 17th. We're going to be looking at transient overvoltages within the installation, those surges generated by the equipment within the installation itself. There's also reference there to another standard, 62305. We'll have a look at that as well. That's the British standard for lightning protection. And the two standards do dovetail together if you're working on sort of larger installations and structures. And also, if you've taken measures to protect against transient overvoltage of atmospheric origin, also known as lightning, pretty much means you've probably covered the switching overvoltage events as well, but a little bit more about that later on. And if there isn't any issue regarding lightning protection, you still have an installation where they may be say a lift or a motor within the installation, and you'll need to address that. So there isn't one solution for any structure. So looking at the relationship now between two standards, you've got, as I say, 62305. That's everything you want to know about lightning. It's 4 volumes. It's despite being on lightning, not a very interesting read. But there are 4 types of damage or sources of damage. S1, which is a direct hit to the structure. S2, which is a near miss, and then we've got S3 and S4, which is a direct hit to an overhead line and a near miss to a buried cable. As electrical contractors, we are only interested in S3 and S4. We're not interested in a direct hit or a near miss. That's the remit of the lightning protection installer. So those guys are going to do a risk assessment. They're going to fit the copper tape on the roof and the down conductors and the earthing system. Your job is to basically plug the holes in the Faraday cage, which is the cables coming from the outside into the building, and you do that by using SPDs. So we're only interested in 7671 regarding surges down overhead lines or buried cables. But the overall standard 62305 is the, as I say, the main document, and a lump of that has been taken out and dropped into 7671, firstly 443 and then 534. So we're going to go back now to the 17th edition. So this is what you've been used to as a risk assessment. And also there was this thing called the AQ criteria. And this is where you had that 25 thunderstorm days a year. Now, I have to say that not many SPDs were being fitted, if we're being honest. We look here at the consequences. So if there's a consequence to human life, public service or commercial activity, they give some examples, and it says there you don't have to do any risk assessment, you shall fit the SPD. Well, there's a little bit of wordplay going on out there. So it says there on indent 2, but if it's say an IT centre, you'd fit SPDs. Well, I'd go to a site and they say, yeah, well, we're not going to fit them. Oh, why is that? Well, it's not an IT centre, is it? It's a data centre. That's not on the list. So this had to be sort of firmed up a bit and get rid of any ambiguities. And what happened is, this is the new risk assessment. This is the 18th edition. So what we can see here, that you shall provide SPDs if the consequence results in serious injury. So you don't have to kill anyone, it's enough to hurt them now. or there was loss of human life, if there was any interruption of public service, and this is a new bit, damage to cultural heritage. So if you're working on any listed buildings, National Trust or English Heritage, you're going to be fitting SPDs to those structures. If there's an interruption to commercial or industrial activity, that's the same from the 17th edition, so nothing new there. And this new one affects a large number of co-located individuals. Now, the word large isn't defined, but this would incorporate, say, a block of flats. It could incorporate a sports stadium. It could also include, say, a music festival, because that's a large number of co-located individuals. Because a temporary installation is the same as a permanent installation, as far as the regs are concerned. So a large number of co-located individuals is new, and that, as I say, will incorporate quite a number of applications there. And then it goes on to say, for all other cases, you're going to do a risk assessment. And then in bold, I've highlighted that if you don't do the risk assessment, the installation shall be provided with protection against transient overvoltages. So it's the case now that you do not leave an installation at risk if it warrants having SPDs fitted. And there's a further exemption, and that's if you've got a single dwelling unit where the total value of the installation and the equipment therein does not justify such protection. Now, that's going to be the smallest installations, maybe, I don't know, like a small workshop or maybe a study area, something like that. If you add up the value of the contents of a dwelling with all the electronics that we have, the LED light in the kitchen appliances, you're going to quickly run up to a value of several £1,000, maybe even £10,000 quite easily. The value of the SPD, which is going to protect that, is nothing in comparison. Now, there's nothing in the regs that says that you have to fit every house with a surge device because you do a risk assessment. But it is quite clear that the exception there is going to be value-based, whereas at the top there, they are not negotiable. Those are going to be fitted where there are consequences, and the consequences are listed clearly. Then it goes on to say that we also have to think about switching over voltages, those events generated within the installation itself. So we've got the lightning risk assessment that we need to think about, and we still have to remember that it could be surges within the installation itself. So the risk assessment, I'm not going to dwell too much on this. I think there's been a lot of other material there, but it's not that scary really. You've got the CRL, calculated risk level, and there are three factors, FNG, and that's divided by LP times NG. Now the regs gives you FNG, and you've got a choice of two. It's either in the countryside or the town. It's either 850 or 850. And the regs gives you that, so that one's easy. NG is the ground flash density. That's the number of lightning strikes per kilometre per year, and that you will see that there's a map in the regs, and you just look up your location, put the pin in the map, and that'll tell you what the NG value is for the location of the installation. What you do have to work out is the LP value, and there are four components to that. There's overhead line, there's buried cables, there's high voltage, there's low voltage. So you will have to work that one out. So looking at an example, when you do the risk assessment, you're going to get a numerical value. If it's equal or greater than 1,000, you don't have to fit the SPD. If it's less than 1,000, you do have to fit the SPD. So I'm going to go for an example. So I'm sitting here at NAPIT's headquarters, and we're in the middle of the countryside. I can see nothing but trees out there. So that gives me a hint I'm in the countryside. So my environmental factor is 85. If I was in the middle of town, it would be 850. The ground flash density for this area, I already know, is about 1. That's on the eastern side of the country. So this is a hot spot round here. And if I was in a cottage down in this valley, it would probably be an overhead line. So I've popped in the value LPAL as being 1. That's the maximum value there. So when I do the calculation for a little cottage in this area, fed by an overhead line, the answer's a mere 42.5. So that would mean I would have to fit an SPD. The biggest factor which would make the difference between fitting it or not is being in the western part of the country and if I'm in a town location. So, having had a look at the risk assessment part, we're going to move on to section 534 now. So there are two main new parts. One is the lightning protection zone concept, which tells us how to fit the SPDs. And then we got something called the SPDA, or Surge Protection Device Assembly. And that tells us a lot about the best installation practice. It's about cable lengths and fusing, stuff like that. So the LPZ concept, what you're looking at here is a sort of an overview of the whole thing. The first zone you'll encounter is LPZ 0. That's going to be broken down into 0A and 0B. Well, what's the difference? Well, 0A is the most dangerous zone. It's an external zone. So if I'm standing up on the roof and I'm higher than those air terminals of the lightning protection system, that means I can be directly hit by lightning. So that's 0A, the most dangerous zone. 0B is still outside, but it's underneath the protection of the lightning protection system on the roof, or it's down the side of the building, where in theory lightning can't get at me. So that's less dangerous. Then there's LPZ1. LPZ1 is the entire volume of the building. So where a cable comes from the outside into the building, that's crossing a zonal interface from outside in, from 0 to 1, and that's where I'll put my first SPD. Now, LPZ2 is going to be a room which is screened within the building, or another screened object would be, say, a control panel or a distribution board. So where I go from the outside into a panel, that's where I'm going to put an SPD. And what you can see is that what we're looking at is any cable. So there's PV on the roof, so they're on the roof, that comes from the outside in, they'll have SPDs. The satellite dish on the roof, that can have an SPD. The CCTV, that can, an external lighting or the barrier entry system, anything like that, where it could bring a surge from the outside into the installation, there's going to be SPDs there. And what you can also see, there'll be SPDs in the sub-distribution system, and then again closer to sensitive loads. So there's going to be a few more SPDs than you might have expected in the past, where people did, to be honest, just put one at the origin and thought, well, that's that. That's no longer the case. And there is a series of regs which we're going to look at now, which is quite prescriptive on how you actually get to this. So in 534, 411, we've got type 1 and type 2 SPDs where required shall be installed at the origin. And then type 2 or type 3, where required, shall be installed close to sensitive equipment. And this is about protecting against switching transients originating within the structure itself. And this is the one which is going to catch you out, 534, 412. In accordance with the LPZ concept, where a cable crosses a zonal interface, further SPDs shall be installed to preserve zonal integrity. So if a designer has gone to the trouble of having an installation protected by lightning protection, and then you take a cable from the outside in, that's a bit of a hole in the Faraday cage. That's when you're going to start installing SPDs to preserve that zonal integrity. The other regs shown there show that we're going to have SPDs which will be type 1 if there is lightning protection on the roof. If it's a domestic dwelling where there isn't lightning protection, you'll have just type 2s in the consumer unit. And then in the last reg there, we're looking at SPDs looking to protect against surges generated within the installation. And all of those SPDs have to come from the same product family to ensure coordination between the SPD types themselves. By the way, if you're working in the domestic market, you've got an external zone 0 and an internal zone 1, and that's it. Houses don't tend to have further screened rooms, so you're not going to have subzones normally when you're looking at domestic dwellings. So that's nice and simple. So what we're looking at here is the relationship between the outside in. So on the far left-hand side, I've marked up LPZ0. We go through the wall, and that's where the surge will come in. So the first surge is going to be, say, a type 1 at the origin, where the service entry point is. The output of that is much lower. And that's where I have another SPD, which is going to be my further internal zone at sub-distribution. And that's where I'd fit, say, a type 2 device. And then closer to the sensitive equipment, I'll have either more type 2 or type 3 SPDs, and that'll ensure that any sensitive equipment just gets really low level surges, so everything's protected. The figures in those blue arrows, they're mentioned in section 443. That is voltage withstand. So at the origin, that's the most robust location. That takes 6 kV. We're interested in protecting appliances, which are rated at 2.5 kV. And you'll see that figure quite a lot within the standard itself. There's a couple of other regs which are interested in this part, and you have to think about those over voltages generated within the installation, and you also have to think about surges coming in other services. So it's all very well having it on the low voltage mains input, but what if you've got an overhead telephone line? What if you've got a satellite dish on the roof? They're all other services coming from the outside in, so you have to consider those as well. And then you have to look at, say, if you've got a house, you've got a buried cable going off down a long garden to a workshop or a home office cabin or something like that. You have to look at that as well. I may have other external installations, so there's air conditioning on the roof, maybe the PV system on the roof, and power lines feeding external sensors. And then the word in there is that these SPDs shall be installed and located as close as possible to the origin of such events. So you want to nip the surge in the bud before it can do any damage throughout the installation there. And then finally, in bold, you're going to have some labels, because when you come to do your IR tests, the surge will see it, dump it to earth, and you're going to get a mad result and think there's a problem. There isn't. It's just that the SPD is sitting there dumping that surge to earth. So let's have a look at an example. This was a very nice country house. It's got some outbuildings there. And because it's a listed building, it did have lightning protection on the roof. So when a contractor approached me to have a look at the SPDs required for this, I was very happy to help. The first thing we need to see, or after we know whether there's lightning protection on the roof, is the electrical schematic. So in this installation, because it has lightning protection, I need a type 1 at the origin, where my main distribution board is down the bottom there. Then on the right hand side, I've got some cables going off to external locations. So they at the far end will have type 2 SPDs because they've left the internal zone, which is protected. Then on the right hand side, we've got some internal consumer units, distribution boards. So they all have type 2s within them as well. And then down the bottom, we've got 5 other SPDs going off to the cottages, stable lot, garage, that sort of thing. And at those far ends, they're going to have type 2s as well. Now, I'm sure you might be thinking, well, that's a bit of overkill, really. Well, when we look at the next slide, I think you might change your mind. What we're looking at is the same installation, and this is showing all the cables going out to the external lights. Now, if I only had one at the origin, if lightning hit anywhere, let's say that tree, there would be a very large increase in ground potential, maybe a couple of 100 kV. And as we get further away, that could be maybe say 50 or 100 kV. So every cable in the ground is going to bring into this installation an induced current. Now, I don't think that those cables actually go to a distribution board, which is where the SPD is going to be located. It might go to a control device, such as a timer or a photo cell or a contactor, maybe a dimmer rack, something like that. Now, I have to think about where these external locations are going to, and would that location within the installation like a surge going down it? So it might be that the SPDs that you've already seen in the distribution boards may not be enough. There may be other locations where you need to think about where those cables go from the outside in. So as I was saying earlier, there's a massive rise ground potential when lightning hits, say, a tree. So in this graphic, using that resistivity, if I can say the word, of the soil, at the point of impact, we've got 15 meg. And after a couple of 100 meters, we're looking at 76 kV. So over quite a big distance, you're looking at some pretty substantial induced currents down any buried cables in the vicinity of a lightning strike. And this is why you can't just think about the origin where the meter is. Are there any other cables buried in the ground which could bring a surge back into that building? Now we're looking at some examples here where there was an SPD at the origin, but that didn't save the house from being damaged. So going from left to right, there's a cable in the garden that's going off to some tree lights. Nothing wrong with that, except lightning hit the tree, and you can see where the cable's trying to rip itself out the ground. It gets to a connection unit on the ring main. So as soon as it attaches to the ring main, that surge, it goes all the way around the ring main, blowing everything up until it gets to the SPD in the consumer unit. If only the SPD was in the connection unit where that external cable joined the ring main. So that would have been an SPD on the 0-1 interface where the cable left from the inside going outside. Middle picture, that was a satellite dish. Do we do SPDs for coaxial cables? Yes, we do. I can't stop lightning hitting the dish, but I can stop the surge from blowing the television up. And then on the right hand side there, we've got an installation where an overhead line was hit. That took out the workshop and all the equipment inside it. So again, if only there was an SPD where that cable came from the outside in. Picture from Germany, we can see where lightning actually hit, and that's what happened on the inside. It blew all the cables out. On the plus side, I can see where I can fit all the cables back in again. Self-chasing cables there. So one of the other things we need to look at is the SPDA, or Surge Protection Device Assembly. Now in this diagram, what we're interested in is the performance of the fuse, the cables and the SPD. This is most important for the Type 1 device because in the regs it says the value of the SPD is 12,500 amps. That's what it's got to deal with in terms of lightning current. So you can't feed a Type 1 device with a 6 Ka MCB. What that means is that during the surge event, the 6 Ka breaker will break, you disconnect the SPD, and then the rest of that surge current goes straight into the installation. The value of the breaker, or multi-case breaker or fuse, must be at least as equal as the surge value of the SPD it's protecting. Otherwise, it's just not going to work. So that's a new thing in SPDA, the fusing. The cable lengths cannot exceed 1 meter and in no case 1 meter. They have absolutely got to be as short as possible. And this is because of a additive voltage, which is going down those cables. Here's an example here, which was rejected. I haven't got a problem with the SPD, you can see there, nice red one. I haven't got a problem with the fusing. It's appropriate for the actual SPD at 25 Ka rupture, but the cables, far too many loops, far too long, and the earth wire, that's about 1.5 meters on its own. I don't know why that is. It's in a metal box. It would have been far better just to bolted it to the DIN rail in the metal box itself. You can use that nut and bolt arrangement as an intermediate earth terminal, and everything is cross-bonded, and it makes no difference whatsoever whether you took it to the MET or the case of the distribution board or the metal consumer unit. That's perfectly fine. And this is why we have to be very careful about the actual cable lengths themselves. Just 1 meter of cable adds a volt drop of 1 kV when I've got a 10 Ka surge going down it. And that little equation down the bottom shows me the value of the total performance of the SPD assembly you saw in that image. So I've got 1.5 kV down the SPD itself. I've got the short cables, 500 volts there, and then the long earth wire, another couple of kV. So that's 4 kV when the maximum permitted value is 2.5 kV. So this gives you an idea of the sort of figures that we're going to be dealing with. And this is what we're going to be looking for, certainly on larger installations, and the same applies to distribution boards and consumer units. We take a connection from the phase bar through, in this case, a molded case breaker appropriate for the SPD in terms of its rupture capacity, and from the SPD a very short stubby cable to the metal case, which is earthed. All of that was done within 630 mil. That's absolutely bang on. That's exactly what we're looking for. In a distribution board or consumer unit, I think you can reach these values in terms of distance, no problem. You've got the neutral bar, you've got the earth bar, you've got an MCB, in this case, feed in a Type 2 device because the regs say 5 Ka is all you need in terms of surge value. So a 6 or more Ka rated MCB is fine there, but on these larger ones, you do have to watch the actual value of the fusing there. And as I said before, the value of the installed SPD, including the link cables and the overcurrent protection, cannot exceed 2.5 kV. And furthermore, if I have an object, say a server rack or something else, which is greater than 10 meters away, I do need to consider further SPDs within the installation because of the rise of voltage down long cable lengths. So that's another reason why I'd need further SPDs in an installation. So getting on to summary now, about to wind this up. Spot the errors, just making sure you're paying attention. Have a look at that for a few minutes. What could possibly go wrong here? Well, that SPD, the blue one, and I'm not picking on the manufacturer, I'm picking on the installation. I've got the isolator just out of shot there. So what the designer here has said, it's okay for the surge to go up and around that slotted trunk in to get to the SPD, and then dump the fault down the earth wire attached to it back into the slotted trunk in there, where it's going to affect cabling and sensor equipment, which need not be affected. So that's not the right way to do it. And the other thing was, this is at a remote location, and although the SPD has the facility to give feedback remotely, it wasn't wired up. One of those blue plugs on that blue SPD on the right hand side there had failed and nobody knew about it. So there was no protection in the installation whatsoever. So what we're looking at is location of the SPD has got to be as short cables as possible, and you've got to locate it at the zonal interface there. So be very mindful about where you're locating them. And that was everything that I was talking about there. And you've got to make sure that your output and input cables don't overlap. And just the final thing is that when you do have cables coming into an SPD, and then you've got dirty or sort of drain cables or earth cables going away from the SPD, don't mix them up. Otherwise, you're going to have a whole lot of problems. You're going to need more SPDs than you would think about. So as an introduction then to 443 and 534, I think the key takeout message is on the risk assessment. There are certainly a set of values or types of installation where you cannot afford to leave out the SPD. That's going to be human safety, public service, commercial activity, and a large number of co-located individuals. And then in 534, you've got the lightning protection zone concept, where you can see how every cable which is coming from an outside location in will need to be addressed. And I'm not talking about, say, on a dwelling like a porch light. If lightning's going to hit your porch light, you don't need an SPD, you're going to need the fire brigade. So that is pretty much it from me, and I'll pass you back to Fran.
Thank you for that. Thanks, Robin, again for a great presentation. I haven't got time to answer all your questions today, or Robin hasn't anyway, but I thought I'd just maybe read out one of them if
Yes,
that's all right with you. So Lawrence Green, one of our members, has asked, in the event of an over voltage, so direct lightning strike expected, and a type 2 SPD fitted, and damage was still sustained to the equipment within the domestic property, what would be the responsibility of the SPD manufacturer to compensate? I need to be able to explain and justify to my customer what the SPD will protect them.
Okay, right. So in a domestic dwelling, you normally just fit type 2 SPDs because there's no lightning protection. You only need a type 1 if you have lightning protection. If lightning still hits a house and there's damage, that's, you're not going to like this, tough, because lightning can still hit a house. An SPD is not protection against a direct hit. If you're worried about direct hits, get physical lightning protection on the roof. If there is still damage, the first question I'll say to you is, when did you last check the SPD? Was it okay last time somebody pushed the RCD test button? So you do have to make sure that these SPDs are always functioning, because as soon as they fail, if no one's looking in the cupboard under the stairs or anything, and that's failed and there's another surge, stuff still gets damaged. So it's not down to the manufacturer, it's down to the homeowner to make sure they're okay. So do wire up that volt-free contact and make sure you know when they failed.
Fantastic. And just one more, because the member hasn't put the information on, so it'd be good to get it answered now. On domestic installations, do SPDs require metal enclosure, as there is a lot on sale in plastic enclosures?
An SPD is not a switchgear assembly. It is a passive device. It generates no heat, and there's nothing in the regs that says they have to be in a metal box. So it's fine to be in plastic, and also with a plastic box you can have a clear lid and you can see the SPD's status, so you know if it's failed or not. It's fine to have it in metal, but it's not required under the regs.
Fantastic. Unfortunately, that is all the time we've got time for today. However, if your question didn't get answered and you've left your details, I'll speak to Robin and get a direct response to you over email. If you have any questions after this presentation that you think of tonight or tomorrow, you can email them directly to nta@napit.org.uk. Thanks again, Robin, for a great and insightful presentation.
Thank you.
And if everyone could just keep an eye on their emails for the next webinar and the roadshows that we have got coming up that might be in your area. Thank you.
Lovely. Thanks very much.
Thank you.
Good evening.